Good morning all, Others Toysent here. I changed my YouTube name recently for digital footprint reasons since the last one was... Never mind. Anyways, the video title tells you the main point. I'm going to use tiers from S, A, B, C, D, or F. Actually, I'm not gonna use S, but you get the point. Also, I made this video since I'm waiting for an email from the Society of Actuarials, that's SOA, from onboarding for taking the Exam P. Exam P is like a sort of an actuary credential related test where a course on elementary probability theory and discrete math will suffice, from what I remember. This video will include mass and density functions. The ones that we're going to include are binomial, hypergeometric, geometric negative binomial, Poisson, exponential, gamma, normal, uniform, beta. Basically, they're just the ones that you should typically encounter in an elementary prop theory course. So, let's start at binomial first. The binomial distribution is easy to the eye, it has simple model and properties, and the binomial PDMF is consistent in a way that it's really good at communicating their emotions. You only get a yes or no at every shot you or they take, and that means this distribution does not ghost or manipulate. And the MGF is really easy to the eye. The form is easy to memorize and you can easily use their MGF technique from the Bernoulli trial. Just like an elective on unemployment studies, I would say the binomial distribution is an easy A. Hypergeometric. Honestly, I'm not into complicated relationships and use hypergeometric if you take a sample without replacement, which of course adds some nuances. And also, from the table that was given to us in our course, it says here that the MGF of the hypergeometric is not useful, which I never used throughout my course, in undergrad by the way. And the only redeeming point is that you can use the hypergeometric distribution to identify how many things are there in all that, if you have a sample of them that are numbered distinctly. So there's the number tank problem where if you have like 500 tanks that are numbered from 1 to 500, and then you have a random sample of whatever number of tanks, I think you can use the hypergeometric distribution to approximate the number of tanks that you got from the sample. So anyways, since this distribution has a D on its parameters, I would serve it a big D too. Geometric. The geometric distribution model is a stopping game, which means you can go and on every session, as long as the probability is like less than 1/10 or half. That's why sure their going session will last for like days. And also, in the geometric functions form of MGF, it's also good to the eyes. Like it's just basically exponentiation. If you exponent R to it, it's gonna be a negative binomial. So the tier I would give it is a B tier. I would have given it an A, but there's a continuous version of the geometric distribution, which means the support is any really greater than 0 instead of just any integer greater than 1. So you get the point. Negative binomial. Actually, I'm personally not a fan of how the negative binomial distribution uses itself. So some definitions consider the event that the last child is a success, so that the x-1 trials have r-1 successes, which if I remember differs in r, so I have to translate the parameters every time I have to manually compute it. So that means n binom is not that consistent, which makes sense is the negative of a binomial. But this distribution is interesting since it's used in math problems that are related to smoking. I'll give it a C for cat ears. Okay, Poisson distribution. I'm not a racist person, so even if Poisson is a French guy, I think that doesn't matter for now. So the Poisson distribution is used in Poisson processes. So in that way, you can easily tell how likely it is for you to GOON to the Poisson distribution. And personally, it's a bit of a personal preference, but the use of lambda as a parameter is so attractive. Like they could have chosen any Greek letter, but they used lambda. It's easier to write compared to zeta, and it's also a popular character. And if you're a sub, you can change the lambda to a beta too. Finally, you can show that you can develop the beta and gamma distributions from the Poisson distribution. And so, even if you're not going to Poisson, you can encounter a Poisson hijack once in a while. So that means I'm gonna give it an A for an apple. Exponential. So, you have to recall the memory list property in grading it, because it's a key component in geometric and in the geometric and exponential distributions. So, what the memory list property basically says is that what happens right now, how likely this event happens right now, does not depend on the past. That's why it's memoryless. And also the exponential distribution is a good option for a switch, since you can change a parameter between beta and lambda. But the thing is, one setup for some of you guys, but not for me personally, is that the exponential distribution is basically the gamma distribution, but it only measures one occurrence of GOONing, since it's the gamma distribution when alpha equals 1. So I'm gonna give it still a B tier, but if that's even possible, I give it a B tier, B+. Gamma distribution. This is a bit complicated since it now involves the gamma function, and you're gonna start using kernels and all that. It's two parameters, alpha and the beta. But I personally like the explanation of the value of gamma of 1/2. And also, the gamma function is also freaky as hell. So like in our final exam, we have to solve a problem related to the inverted gamma function. Like, I think we had to find the function itself from scratch. Yes. I mean, I did not get it entirely, but I remember it involves simple integration with joint distributions to make a sort of a kernel, something like that. And speaking of kernels, I actually like the gamma kernel. So, as I've mentioned from exponential previously, it allows multiple instances of GOONing in one session. I like the exponential function, which is a stopping game. And with that being said, I'm not into wild math problems in long tests, so I'm gonna give it a C = 3. Normal distribution. That's a given. We all know it. I always use a CLT. I'm a fan of the normal kernel, so that's an A tier. Uniform. Even if it's a very simple distribution, you think it's just lame or vanilla, this PDF is so powerful. Like, when you think of it, you can show that basically every PDF that you're going to GOON to can be transformed into a uniform distribution to the PIT. So, reflect on this. In your entire life, all you have been GOONing to is the 1 minus B minus A, provided that B minus A is greater than 18. I would have given it an A, but actually the form itself is so simple and vanilla. Like, I'm looking at right now in the mean, the variance, the MGF. They're just pretty simple actually. When I tried solving some problems related to uniform, it's just usually time problems, interval problems, or the like. Or maybe I'm just an undergrad. Anyways, that's it for uniform. I'm just selling it to the B for banana. Anyways, finally is the beta distribution. Actually, low-key, beta is a good one. It's good to the eye, especially with cancelling like terms of the gamma functions when solving problems. Because when you're trying to solve some of the math problems, like you have the gamma of A plus B and the gamma of A, the gamma of B. You have to manipulate the forms of whatever, so you have to do that. And also, the other terms is just basically IBP. So it's x raised to alpha minus 1 and then the 1 minus x raised to beta minus 1. So, this solving problems related to beta distribution is so interesting. I think you have to use either beta or gamma to derive or to discover the student's t distribution, or I think the chi-square, whatever. So, but the thing is, the support is limited to 0, 1, which is limiting, and it's actually short distribution. So I'm giving it a B for Bonanza, or maybe a B plus if I'm really generous. So I think that's all for today. Yeah, I think that's it. I think you should like and subscribe to my channel, and I think you should study math. Thank you.